Okay, hey everyone, this is Joanne Panzardi. I'm the chair of the engineering department, teach a number of classes. The last 9 years, I've been running some grants that have pulled me out of the classroom somewhat. So I'm not teaching as much as I used to. The first grant remodeled the whole 800 building and gave you the STEM center. And then the second grant that I'm working on that only has this last year, this is the last year of it, was creating ag tech programs and also environmental science programs. I love teaching statics. So let's just start out. So I'm going to write some notes down. I'm going to zoom in, but all this is recorded and notes will be published, so you'll have everything. So taking notes isn't as important as just do whatever you need for your own learning. So in a statics class, typically a third of you have already taken materials, the materials course. A third of you are taking materials now, and then a third of you will be taking materials next fall. So for those of you that took materials already, I don't think that Carl has talked about materials yet, properties yet, but there are properties of materials. I want to see how well you could actually see what I'm typing. Probably better now, correct? You guys? Okay.
Yeah.
So for properties of materials, there are, do you remember, those of you who took materials, what are properties? This is always going to be hard getting responses from you via video. So often I might just answer the questions, but it's how a material behaves when subjected to a stimulus. So there are different types of properties in materials, and I want to talk about the properties and the stimulus. Stimulus. So in case of a situation where we're dealing with thermal properties, how a material behaves, thermal properties, what do you think the stimulus is? What is the material being subjected to for you to see how it's going to behave when it has, through its thermal property? What do you think?
Heat.
Heat. Great. How about an optical property?
Light.
Light.
Hey, Joanne, can you zoom out on the notes? It's
Sure.
yeah.
Yeah, I need to keep moving up, huh? And then my name is in the way as well, huh? Boy, this is going to take some getting used to. Can you still see the words?
Yep.
That's good.
Okay. Okay, electrical properties. A current. How about a magnetic property?
Magnetic field.
Yep. And the one that's most important for statics, a mechanical property. Those of you who took materials already, mechanical properties are elasticity, plasticity, toughness, resilience, strength. What is the stimulus that is applied to a material in order for you to look at mechanical properties?
Force.
Yeah. A force. And a synonym for force is load. This is what we're going to be dealing with in statics the whole time. We are looking at the study of mechanics and mechanics is broken up into two groups, statics and dynamics. Statics is the study of what? What do you think the difference between statics and dynamics are?
the full body diagrams add up to 0.
Okay, and so what are you trying to say, Angel? When you add up all the forces and it turns out to be 0, what are you telling me about the body?
There's no net force on the body.
Well, there is a force on the body.
No net force. Though,
No
right?
net force, correct. We could also say it's non-moving. Because if there's no net force on the body, then we're looking at a non-moving body. And dynamics, we're dealing with moving bodies. In both statics and dynamics, it might be better in the future for me to write straight on a computer screen. Oh, shoot, I'm gonna share. Can I do that? Oh, you guys know that you could change the speaker view, right? To make this larger for yourself, right? Because right now it's important to me that I see your faces while I'm teaching. Hey, Jordan. And Matthew, hi. But for you, it's probably most important to see what I'm writing. So make this your large view. Okay. Okay. In both cases, whether we're dealing with statics or dynamics, again, we're going back to mechanics. We're looking at how a body behaves when it's subjected to loads. We're going to be dealing with the three Newton's laws.
For reference, the word mechanics is cut off on my screen. I imagine it's the same for other students.
Okay, I'll move it down. Good?
Yeah, you could zoom out as well.
Okay. All right, let's see. Well, if I zoom out, then it makes it smaller. Is that?
That's okay for me.
That's totally fine. Yeah,
That's okay?
that's you could zoom out another 50% more and we'd still be
Yep.
fine.
Yep.
That's okay still?
Even better.
Yeah?
Yeah,
How's
that's
that?
great.
Yeah.
Yep,
Whole page
totally,
is fine.
totally
Yeah?
real.
Okay, awesome. Okay. All right, so Newton's laws, there's 3 laws, right? I don't know if you know them in order. One is object remains at rest. What is it? Object remains at rest as long as no external force is acting on it. The second law, F is equal to ma. And then the third law is that there's equal and opposite. So we have A and B. We have both of them. The forces are equal and opposite. I'm just doing a little shorthand right now. So what Angel said is that when we're dealing with statics, we're dealing with the sum of the forces are equal to 0. And if we're looking at a 3-dimensional body, the sum of the forces in the x equals 0, sum of the forces in the y equals 0, and sum of the forces in the z equals 0. Knowing that the sum of the forces equals 0, and knowing that F is equal to ma, can you think of a time that you could use static analysis when something is moving? So let me repeat the question. We already said that statics is the study of non-moving bodies and how it responds when we apply a load. Dynamics is the study of moving bodies. Knowing that statics, when it's not moving, all the forces in all the directions are equal to 0. All the forces are equal to 0. And we also know F is equal to ma. Can you think of a time that you could use static analysis when something is moving?
Yeah, maybe falling in free fall, like terminal velocity.
Or just 0 acceleration.
Yeah, David, I'm stumped on that question. I'd have to research
What
that
about
a little more.
rotating?
Hmm?
Does that count
Well,
as moving? What about something like spinning?
Great idea. So let's even extrapolate that. When we deal with statics, we're saying that all the forces, there's no linear motion. Some of you may have already watched my little lesson on motion. And there's also no rotational motion. That means that the sum of spinning, in physics, we call it torque, but in engineering, we call it a moment. So when we're dealing with statics, we're saying that there's no linear motion and there's no rotational motion. But going back to my question, can I apply analysis of statics to something that's moving? And somebody said it. I don't remember who said it. Was it Tim?
Was it
Say
zero
no.
acceleration?
When the acceleration is 0. So when you have acceleration equal to 0, you still have it moving, but there's no change in velocity. And it means that if acceleration is 0, the sum of the forces are still 0, and we could use static analysis. Okay, so the point of this for you to know is that when we're dealing with statics, we're looking at forces on bodies. Okay, so typically electrical engineers don't take statics. A bioengineer who's a genetic engineer is not going to take statics. But which engineers are dealing with forces on bodies? There's a ton of them. Mechanical,
Civil.
aero, civil, structural, environmental, biomedical, architectural, aerospace, aeronautical, marine engineers, ocean engineers, and the list goes on and on and on. In fact, this is the most important class that you take at Cabrillo. You may come into statics thinking, oh, well, the math and physics is more important and chemistry because they're 5 units, but that is not true. This class is only 3 units, but this class is more important. You are finding how to use math and science to be an engineer. And I'm going to keep talking about stressing that as we go on. Right now, I'm going to share my screen and we're going to go to watch some videos of things that you possibly may be designing when you're an engineer that really rely on statics. So I'm going to go to, just check to make sure my courses are open. I went into Canvas and I have this error message that says 502 bad gateway. So let's figure out how we're going to deal with that. Okay, it just got stumped for a moment. Okay, so now I'm going to share my screen. And I'm going to the Canvas page. And does everybody see the Canvas page? And we're going to go over this Canvas page in detail later. Right now, I want to introduce you to statics. So I'm going to the module for today's class. And I'm going down to engineering videos requiring statics. And some of you may have watched these already. Okay, so let's go to another one. So you can see how each one of those things that engineers would be designing would be involving forces, whether it's forces from the road, whether it's forces from the person. And we were looking at vehicles, we're looking at sports, recreation. Okay, now we're going to look more at biomedical. We're going to just watch the first minute or so of this one.
You lose your arm and it's like, oh, woe is me, life sucks. 6 years later, here I am, hopefully about to develop some of the best technology for people out there.
Evolution doesn't stop just because we are here. We probably are becoming the first species that is capable to influence its own evolution.
I could have this hand look any way I want. What if I don't want a hand? What if I want a tentacle?
Modern advances in the world of prosthetics are changing lives across the globe. Where once there was stigma, amputees are now empowered and enhanced. From low-cost 3D printed designs to high-tech innovations, I wanted to see how access to these technologies has changed, what further developments are around the corner, and what ethical battles lie ahead.
So those we were looking at some biomedical options. Okay, let's take a look at this one now. This is a bridge. This is the one static. So this is anyway, we'll just. So this is a bridge in Dublin, Ireland. It looks like a harp. Pretty cool, a creative design. It was designed by a Spanish architect, Santiago Calavera. He also did design the bridge up in Reading, the Sundial Bridge, if you've been there. He designed part of the Freedom Tower in New York City. It's really amazing stuff. I do hear that his projects go over budget though. And the person in our department that knows most about bridges is Karen. She loves bridges. So now we're looking at some structural project where we looked at a biomedical devices, we looked at recreational sports devices, and now we're looking at a civil engineering or structure or architectural. Okay, and then the last I'm going to show you, I showed in my engineering 25 class. And this photo, you know, I approached engineering 5 and 25 saying, is this real or not? I mean, the photo definitely is great and their colors, but this is real. This is a cruise ship called the Concordia, where the captain of the ship got too close to the reefs off the coast of Italy, and it capsized. And you may have heard it happened about 10 years ago, and the biggest press that it got was that the captain jumped ship, literally, when it went over. So he was, I don't know what he got charged with, but he got charged with something. But certainly, again, we're looking at loads again on something. So when engineers design this, they need to involve a lot of statics. And of course, even when you involve dynamics, you're first starting with statics. It's a similar analysis. And then I wanted to show you a video because in addition to engineers being involved in the design of the cruise ship, they were involved in the design of how to get it back up with all the constraints they had. They didn't want the reef to be damaged anymore. They didn't want the gasoline to leak out and fluids. There are a lot of criteria on this. So let's watch this video for a moment.
The Concordia lies on its side in a protected environmental marine just off the island of Giglio in the Tyrrhenian Sea on the coast of Tuscany. A complete analysis of sea life and water quality, including mapping sea grasses and coral, will take place prior to the start of the recovery. The 44,600 tons of the Concordia make this the largest and most complex recovery ever attempted. The first operation will be to prevent the ship from sliding down into the depths of the sea. This will happen by attaching it to heavy cables connected to poles that serve as holdback. The second operation will be to install steel plate slings to support the hull, and to which we will bind more holdback cables and, later on, flotation tanks. The third operation will consist of placing large sand and cement bags beneath the hull to hold the steel plates and further support the hull. Restraining poles will be drilled into the seabed using a closed circuit technique, which guarantees no debris will contaminate the water. In the meanwhile, subsea platforms will be installed to support the ship. These platform sections have a dimension of 40 by 40 meters and will be anchored to the seabed through the restraining poles. Floating tanks will be welded to the hull on the port side of the ship. With flotation tanks and pullers in place, the ship will be ready to move back to its natural position. This will be done via a pulling machine, which slowly rolls the ship upright. The holdbacks will assure the ship does not slide down the seabed. To finalize the operations and to make the ship float again, the tanks will be emptied of the water they contain, and this will be replaced with air, so lifting the ship from the seabed. Once the ship has departed, we will remove the entire structure used during the recovery operations. Poles will be cut at the seabed level, platforms will be removed, and the seagrasses replanted. Great attention will be paid to the marine environment, including water and air quality, taking all precautions to avoid any type of contamination. We intend to do everything possible to restore the original environmental conditions of the island of Giglio.
Okay. Okay, I'm going to stop sharing now. So, and I'm going to shut this off. So it's me.
Did that ever happen? Did they complete it?
Yeah. Yeah,
Wow.
they finished it. It was a while ago. So you could take a look at it.
There's a much longer video that's amazing that shows the whole
Yeah.
process.
Yeah, I picked the shorter one.
Ah, gotcha.
Let me start video. Okay, here I am. Okay, so now as I said, so you just saw like 4 different examples of different types of products that engineers design, and it's all based on the study of forces, and that's what statics is all about. You've been introduced to statics a little bit in Physics 4A. In Physics 4A, you started doing some statics problems. I believe they're all 2D. But Physics 4A has so many topics in it that the statics part of it is a really small part. And a lot of times when you're doing those static solutions in physics, you're really doing it as if you're writing on the back of a napkin. You're just kind of trying to get through it to get the numbers. The important part in this statics course is not only understanding how to solve the problems, but presenting them in a manner that is the way an engineer presents problems. It's very methodical. Almost all of you have completed homework 1 and 2, and when you watch those videos, you learn that I'm very methodical. I want things presented in step by step. And whether Carl was teaching this class, or Karen was teaching this class, or Kelly, or Rob, who I'm teaching the lab, he's teaching the lab part, or Russell last year, we're all presenting to you the importance of being engineers and setting up problems in a step-by-step procedure. And the reason why is because when you're doing design, your designs are always checked by at least one person. Quite often your boss, many times your peers. It is really important to make sure that you're very methodical. So not only is the solution important, but even more important is your setup. And I will walk you through how I want everything set up. And I'm going to be really particular about this, because by the time you leave my class, you're not going to just know statics, but you're going to know how to present engineering solutions in a professional way. Everybody get that? Okay, so I'm a little anal. but it's important because I want you to be able to present the problems thoroughly. 2 alumni contacted us in the last few years. One was Heather down at Cal Poly. You might know Heather. She was originally going to go into civil. She wound up going into mechanical. In any event, she sent me an email saying, you know, Joanne, I remember when I was taking statics, students were complaining a lot about how methodical you wanted everything set up and the given and the find. And she was like, that's all they want here at Cal Poly. Another student, Mark Schisler, was a TA for statics years ago, probably about 10 years ago. He was thinking about whether to go to Cal Poly Pomona or San Luis Obispo, and he went down and visited it. And he sat in San Luis Obispo's statics class. So he went down to Cal Poly to visit. He sat in their statics class, and a teacher asked somebody in the class to come up and solve a problem, and nobody in the Cal Poly class would. But he was sitting in the back as an observer, and he was my TA. So he raised his hand. The guy didn't even know he wasn't in his class because at the university, classes are big in the first 2 years, even Cal Poly. And Mark went up to the board and solved it, and the guy was like blown away. So you may not know it now, and you may think that I'm being a pain in the ass, but you're going to find out that when you're an engineer and when you're in your upper division classes, that it was totally worth it to follow things methodical. You'll have less errors. It's easier for someone to check. You could go back on it. Let me look at my notes. Less errors. Your peer and boss could check. It's professional, and it's how it's done in the work world. Okay? How to be successful in statics? You have to solve lots and lots and lots and lots of problems. I gave you the link that Nate Preston gave me to get all free textbooks. I'm not sure if I was supposed to give that to you or not, but I think it's important, and I really care so much about you guys. You have a free textbook. You also have, if you looked close, the solutions manual. You could do a ton of problems from the textbook. You have all the solutions. Now, does the solution manual solve the problems the way I do? No. Because the person who did the solutions manual is some grad student. Not a professor wrote the textbook, the grad student did all the problems. I want you to set up the problems the way our engineering department wants you to set up the problems. So the setup is not going to be there, and remember, the setup is important. But what will be there is the numerical values. So the more and more problems you do, and the more answers you could check, the better you're going to be at statics. Okay. I'm going to give probably 2 homeworks a week. When we weren't online, I would give 1 big homework assignment a week. And I think that's not going to work for online. I want you to do a little at a time as we go along, so I could constantly check to see where you are. So you're going to get maybe 3 or 4 homework problems twice a week. But in addition to those, you could do a ton of other problems. And during my office hours, you could come in and say, hey, Joanne, I tried to do this number 34. I can't figure it out. Could you help me? But in class, we are going to go through setting up a ton of problems. The math part is not that important. You know how to do math. It's the setup. It's the statics part. Okay, I feel like I've been talking a lot so far. So let's just take a 5-minute break. Okay. And what I did learn is that when I'm going to stop sharing, well, I'm not sharing right now. I could pause the video and then I have to start it again, but it all comes on the same link. So right now I'm going to pause it. Oh, okay, Adam, I see a question, but I'm going to go on, and during the next break, I'll answer that.
Sounds good.
Okay, so actually, I'm going to just read it. Hello, Professor. I have a question for homework 1, 2D components. I can't access the PDF with the question. When I click on it, it sends me to a different page and says unauthorized. There are like 3 of you that has happened to. I would just go into a different browser. I don't know what the deal is, but 3 of you got something that says unauthorized. I don't know. So if you keep getting it, which it sounds like one of you, and I think it was you, Adam, got it a couple of times, just use a different browser because the file is there. Okay.
All right, I'll try that. Thank you.
Okay. And the other thing I had to do once, I hate to say this, but one time I had to close out my whole computer and restart when I had a problem. So Daniel, you had the problem too. I did send the files via email as well, but you guys have to figure out what it is, and I'm going to show you ways to solve your problems in Canvas. Okay, so I am going to share my screen now. And so right now I'm on the Canvas page for statics, and I did put it in student view. Do you see this pink at the bottom? Yeah, so that's for me, that shows me that it's in student view. So it's what you see. I have to move your photos somewhere. So what I notice, I'm on the home page, and you can tell I'm on the home page, right? What I learned from the student view is that you actually on the right side have to do the items that you have to do. Okay, the to-do items, which I don't see on my instructor view. Okay, so notice for Canvas, so right now what I'm going to be doing is giving you an overview. I first started this class by telling you the importance of statics and how it applies to engineering. Now I'm going to show you the Canvas page and walk you through this. And then the last part of this class, I'm going to have you do some breakout groups to get to know each other and work on a workshop. Okay, so in the student view, you're going to see announcements, and I'm going to be sending you guys announcements. So one key thing I understand is that every time I post something to Canvas, to this page, you guys should get some kind of email saying that I posted something. If you're not getting an email, you need to figure out how to get it. Or if you don't like getting all those little announcements from me on your email, fine, turn it off, do what you want, but just realize that I am updating things on this page. So announcements are things that I just want you to know, like right at that moment. I'm teaching through the modules, and we'll look how that's arranged soon. Then there's a discussion post, and you guys have already started doing that. There's a discussion post 1, which is really a get to know each other. And then there's a discussion post 2 on 2 inspirational videos that I found. Confer Zoom is how you're going to access the Zoom, but you can access it not through Confer Zoom too. You could just do it through the Zoom page. All Tuesday and Thursdays have the same Zoom number, but the Friday lab class has a different Zoom number. And then you'll be able to check your grades, and you'll be able to see all the names of the people and contact them through Canvas. So these are the ones that you have access to. In addition, there's something called Calendar, and some of you may have used it and some not. And I'm going to see if I'm going to open it in a new window. I'm moving your photos over again. So on the right side, can you see my screen on the right side? It says Engineering 35 and it's green. Do you see that? Edgar, I see a question mark on your face. Do you see the green? Okay. Okay, so green represents statics. So you guys could choose whatever colors you want. I happen to choose green. So if we look at August, it lists all the due dates on everything. And most things are due at 10 p.m. Okay, but remember, I'm team teaching this class with Rob Weiland, who taught statics lab last year and taught the lecture and lab the year before. And he's going to post due dates too, and he may not use the same time as 10 p.m. So you're just going to have to keep track of that. Okay, so on each date, it says what is due. Okay, so you'll see you have a number of things due this week. And I'm on August, so now I'm going to go to September, and you'll see that again, you saw the 1st to the 3rd anyway, and then you have the 7th here. So one way to actually look to see what's due is the calendar. I'm going back now to the home page. Another way to see what's due is on this right side of the home page, which for me is not so clear, but you might like that. And then the other date is by looking in the modules. So I'm going to just open up the announcements for a minute. So far I posted a number of announcements, 5 of them, but I started posting them. Let's see, lecture and Zoom classes, start dates and homework due dates. Actually, the homework might even be in here for those of you who have not submitted homework. I don't think I put it in there. My office hours on Monday through Friday from 1 to 2. So you can remember that, 1 to 2, every day I'm available, and I'm always available through the STEM Center. So I'm going to the same virtual STEM page that you would go, STEM Zoom link that you would go to the STEM Center, so you have less to remember. The reason I picked 1 to 2 is I'm the one who designs the engineering, math, physics, and chemistry schedule. And you guys, if you're not taking a GE class, you're mostly free from 12:30 to 2:30 every day, with the exception of a GE class, with the exception of one Physics 4A, B, or C lab, which there is one section from 11 to 2:10, and then some chemistry. So the fact that I'm available every day during those times, hopefully at least one of those days work for you. So these are the announcements. Discussions you've already posted to, and now I'm going to go to the modules. And this is where we're going to spend most of our time right now. And there. Okay, can you see this? Should I make it bigger, or are you guys okay? All right. I only see
That's
4
good.
faces right now. I see Marcine, Amani, Daniel, and Edgar. So I'm really just looking at their faces and determining whether they say yes or no. Okay, first module is called Understanding Canvas and How to Get Help. Okay, I am not an expert at Canvas. I'm nowhere near an expert. I took a 2-week class this summer to try to prep. I know more than I knew last semester, but I'd much rather be standing in front of the room teaching you guys. Okay, so this is where you could get help. This is getting started with Canvas. It tells you how to organize your Canvas page. This tells you how to get tech support. Some of you might know about the Computer Technology Center. The CTC is a room, a huge room full of computers. Well, right now, there are no computers in that room because all those computers have been loaned out to faculty and staff. So what are those people doing in the CTC if there's nobody to help? They are helping you with Canvas, big time. So you have a Canvas question, you go to them. Don't go to me. It'll take me forever to figure it out, and it's a waste of time for me and for you. They know everything. You want me to spend more time on statics than on all this other stuff. We changed textbooks this year, and I've only done the problems in the first 4 homeworks. I have just as much homework to do as you do because I had to spend all the time getting ready for Canvas. But from now on, I want to spend way more time in statics. Discussion tips, and here, I already graded your first 2 homework assignments. Not many, a number of you did not follow the steps I want, so I gave you a 2 out of 3, and you could resubmit your homework. Okay, so you want to know how to get the comments. I read everybody's homework and I submitted comments. And in graphics last semester, I showed the students where I put the comments, but it didn't help them finding where the comments are because it's in a different spot for you. So go here and figure it out. But read my comments so you know how to do the next problems better, okay? And if you got a 2 or lower, resubmit it, but I have a due date. It has to be resubmitted by Thursday night. It's on the announcements. Let's go back to the announcements for a minute. Homework 1 and 2, submit and resubmits. So a few of you haven't submitted the homework yet. It's all due by Wednesday at 10 p.m. So not Thursday, Wednesday. Okay? Because I need you to know it by Thursday. Okay, I'm going back to modules. All right, so I'm going to close this module now.
Do you know if the is the bookstore open right now? Because I know they have engineering paper there.
You cannot go to the bookstore. You have to order things online and it gets shipped to your house. So I imagine you might be the same way. You're not reading all the COVID links and fire links on the Cabrillo College site, but I'm telling you, a hell of a lot of people at Cabrillo have been working to get you guys all these services and telling you what's going on, and it's all on those pages. So go to the Cabrillo main page and click on COVID. And you can click on the fire thing too. And it tells you exactly what's going on with the bookstore, what's going on with this, what's going on with that, what's going on, how to get free this, how to get free that, how to get free this. Take advantage of all these things. And I've been posting a lot of this stuff to the engineering student Canvas page as well. There's ways to get free webcams. There's ways to get free hotspots. You got to follow the directions because there are 4,000 students at Cabrillo. And I hope that by me getting you the information, you jump on it before everybody else does. Okay? Okay. Next module is summer work. It's all about components. I'm starting each module with something that I was taught during my Canvas class this summer. So probably all faculty are doing it. If you open it up, if you open up the overview, it says what the goal is of that module and what you're going to learn in the module. Okay? But you don't have to read it if you don't want to. But if you want to know what this module is all about, read it. But otherwise, you could just go to all these things. There's a 2D component video. There's a 3D component videos. There's a homework, and I posted the solutions. Okay? What the hell is this over here? What does this mean? I'm in the student view. I don't know what that means. Oh,
I
maybe
think that means it's past due.
past due.
Yeah, or you haven't submitted it.
Oh, okay. If something's past due, can you still see the homework assignment? Yes. Okay. Okay, so that's that. I am giving you solutions. Actually, we'll go down. I'm posting these solutions so you can check your work. And as we go along, we'll talk more about posted solutions, although you do have the solutions manual. Okay, I'm gonna just stop sharing for a minute so I could kind of see everyone. Does anybody have any questions about the first two Canvas modules? The first module is how to get help with Canvas. The second module is the summer work. Okay, let's see.
I have a question about the summer homeworks. I don't know if that should be saved for an office.
No, do it now.
The comment I got was about the force body diagrams, but in your
Yes.
solutions, they don't have them. So I wasn't sure how to do them right.
Yeah, so I'm sorry. So the free body, we're gonna learn a lot about free body diagrams. You're gonna start actually right after today because one of the videos is on it. And then we're gonna be looking at them a lot on Friday, you guys with Rob. So I'm using the generic term free body diagram. Typically, you are choosing which body to draw a free body diagram of, and then you draw the free body diagram. And we're going to be starting to do that on next Tuesday, a week from today. Right now, what I wanted you to do is just draw the sketch that was given in the problem. And the reason why I'm having you do that is because I want you to get more comfortable with sketching in 2 and 3D. I realize that almost probably 3/4 of you took graphics already. So you guys are a little bit ahead. But those of you that didn't take graphics, you may not be that comfortable drawing in 3D and seeing in 3D. So you need to do that, and you need to practice doing it. Because during an exam, well, during tests, if it's timed, if it takes you forever to draw a 3D sketch, you're not going to have time to do the statics problem. So you need more practice. So those of you that I wrote that didn't include the free body diagram, I want you to draw them and then just resubmit them. So you could draw, you could take your homework 1 and just draw the free body diagram on homework 1 and just resubmit the same homework. David?
I guess that's my question, because it felt like drawing what was already there. We weren't adding anything to it. We weren't changing it. You just want us to practice drawing.
I wanted you to practice.
Got it. Okay.
Right, but the next time when we start doing more problems, we'll see. The next 2 sets of homework are similar. You're just redrawing it. But starting next week, we're going to be drawing our own free body diagrams. Everybody got it?
Thank you. Yeah, thank you.
Thanks. Any other questions regarding Canvas help or the homework 1 and 2?
So you said that we have to use engineering paper, right?
Yes.
And previously you said that you only use the front side. So
Yeah.
we're only going to use the front side of the engineering paper for the homework. Okay.
Right. So actually I probably didn't, yeah, I think the syllabus says front side only. So you'll notice engineering paper has a dark grid on the back. And because it's so dark, you could see it in the front. You only write on the front side of engineering paper. The back side is just a grid to show through. It seems like a waste of paper, I'm sorry. But this is how it's done as engineers. In fact, Mackenzie, are you the one who brought in graphics, engineering paper from your company?
No, it wasn't engineering paper. It was just like this notebook.
Yeah, it's it. Could you hold it close to your camera? So Mackenzie is interested in geotechnical engineering. She works at a company. And it's hard to see in that small screen, but that's engineering paper. It doesn't look like our green paper. It's white. Each company gets to decide. All the companies I've seen have it as white, but they have their logo at the top. So Mackenzie, could you show it again?
Yeah.
So the company she works with logo is at the top, and then there is that light. You can't see it, but there's a grid on there. That's engineering paper. So Mackenzie, you could use that if you want instead of buying the green stuff.
Okay.
When you go transfer the university, you're going to see the green stuff all over. So that's why we have you do it at Cabrillo. But don't worry, order it. When you get it, you get it. Okay? So I'm just going to assume that you're ordering it. And if the next homework 3 and 4 is not on engineering paper, I'm going to just assume it's in the mail and I'm not going to say something. But by homework 5, you should have engineering paper.
What's the difference between engineering paper and graph paper?
Graph paper tends to have darker grid on it. So when you write on it, it's kind of harder to read. Where the engineering paper, the grid is really light. So you could use it to do a sketch and help you sketch, but it doesn't take your attention away from the actual calculations and design you're doing.
I do all my work digitally. Do you want me to switch to on paper, or can I just find it in?
No, I mean, okay, all right. I should have started off the class by doing this, but I zoomed right into statics. We probably all had a hard summer, maybe. And I hope that you're doing well, and I hope that everyone's excited to come back. I'm really excited to be back. I really kind of need the social interaction with you guys. This isn't good enough for me, but it's better than not seeing you. I also know that some of you have been through some really difficult times. COVID is terrible. And then the fires have been terrible. So I know that you're all kind of strapped and all stressed out. One, I'm not just here to teach you statics, but I'm here to really be your support getting through the engineering program. And I could be a therapist if you want. I could be whatever. I could help you figure out universities. I help you do scheduling, whatever. I'm here to do whatever you need. I don't have a degree in therapy though, but I can help. But you've been through hard stuff and some of you have lost your jobs because of COVID. So I realize that some of you might be strapped. So if I need you to determine for yourself, if you can't really spend the money on, I mean, I got the textbook for you free. So I'm hoping that's a help because this textbook, even though it's an old book, it's still about 50 bucks. Other old textbooks are like 20 or 10, but this one you can't get, I could not find it for under 50. So you have a free electronic copy. If you can buy the engineering paper, I prefer it to be on engineering paper. But if you have to do it another way, and Jordan, to answer your question in a long way, sure, if you want to do it electronically, that's fine, okay? I just want it neat. I want it on one PDF file, and I want it upright, okay? Because the more I have to do to get it in the way I want, the less I could do in statics, and I don't want to do that, okay? Okay. In the chat, somebody said you could buy it at Staples or Office Max. You could probably buy it from Amazon and have it shipped the next day. Okay.
Amazon's next day shipping has been questionable lately.
Okay.
All shipping, pretty much all shipping has been fairly delayed, even when they say it's 2 days, but not just Amazon.
Okay. All right. In any event, do what you can do. Okay. If you have situations that you're in that are really taxing, please let me and Rob know. We got to know. If I don't know, if you're not turning in homeworks and I don't know your baby's in the hospital, what the hell am I going to do? You know, I need to know. You got to tell me. All right. Keep me posted. Okay. I'm going back to the screen now. Okay, so about our engineering course, this is the same information that's on the home page, which basically gives you a description of statics, gives you what you will get out of the course by the end, and also a list of the topics. So let's go to instructors now. So instructors, so Rob and I are team teaching the class. I'm teaching the lecture. Here's a little bit more about me. If you want to contact me. We could talk during lecture, any of my office hours, or message via Canvas. What I'm trying to do this semester is keep all the statics questions in Canvas. Okay, so I will be checking the inbox in Canvas. If you have a question regarding statics, send it to Canvas. Don't send it to my email. I get tons. I get at least 200 emails a day. Okay. And then here's Rob's bio. And then he has office hours Wednesday evening. Again, his office hours are in the STEM Center too. And him also, message him via Canvas, not through his email. And then we have a TA named Andrew that you'll meet on Thursday. Okay, here's the syllabus. We'll go through it in a little bit. Academic integrity. I'm going to open that up. And all this stuff, I expect you to, read through it thoroughly. It talks about what honesty is, but what I want to go through is, okay, 1, don't cheat in the class. It could result in 3 things. Oh, you can't see my 3 fingers. It can result in 3 things. Never cheat anywhere at Cabrillo, never cheat in academia, period. 1, you could get a 0 on the assignment or the exam. 2, you could get a failing grade in a course. Or 3, you could get expelled from a college. Don't try it, okay? It's not worth it. It really is not worth it. But that being said, let's talk about what we do as engineers. I wrote, engineers work in teams, and we expect you to help each other and work together on homeworks and lab assignments. However, the work you submit must represent your own work. What does that mean? Let's say David and Edgar are sitting next to each other somewhere else outside of school where they're allowed to social distance only 6 feet. And they're doing homework number 3. and they're both talking together. Well, how did you approach this problem? How did you approach this problem? You could talk about it. You could show each other. You could teach each other. But ultimately, you are writing your own homework. We don't want to see identical copies of homework. And I don't want to see identical copies of the solutions that you have access to. For one, the solutions, the way in the solution manual isn't the way we're presenting statics, because we're teaching it in a methodical way. 2, you have to own your own work. Like I said, for those of you that are mechanical, aero, civil, structural, biomedical, architectural, marine engineers, this is the most important class you teach at Cabrillo. We teach at Cabrillo. Well, I should say that you're going on to dynamics and strength of materials, but some of you will not. Statics is the most important. It is the prerequisite for every other class you take in the future. Own it, do your best, and do it neat. Anything you do reflects who you are. You want me to write letters of recommendation for you in the future? Submit clean, neat, professional work. Don't give me scrap work, okay? Okay, so you could work together. Quizzes, however, must be completely your own work. We use the quizzes as a way to assess what topics you are understanding and those that you need more help on. If you cheat on quizzes, then I think you got it and you understand the material, but you don't. And if you don't, then I can't help you because I don't know you don't know it. All right? Okay, let's go back. There is, everybody looking up here, trigonometry, geometry rules. There's a page in here that talks about, that shows you all the geometric and trigonometry rules that you need to know. So basically review it, okay? I know that those of you who took trig in high school, you're awesome. Those of you who didn't get a chance to take trig in high school and took trig for 2 weeks in math 4, you might not be as proficient in trig. So make sure you go through these rules, okay? Engineering videos we already looked at, and now here we are, first class icebreaker and dot product lab activity. So, but I'm gonna go on a little bit. Here's the homeworks. Here's the dot product lab assignment that we're gonna be working on today in your breakout group, but although it's 10:40 already and you only have 10 minutes. So that's not so good. Student information sheet, it was already due, turn it in. Discussion posts, it was already, some of it due already, some not, do it. There's a quiz, and I'm gonna open this quiz. Hopefully everybody's still with me. Open this quiz, it says, oh, it's locked. That's a pain. Because the directions are on the quiz. All right, so I have to write up the directions. That's a problem. Okay, so, okay, let me explain this. What this quiz is, it says, watch these 4 videos. Watch these 4 videos. They're each maybe 6 to 9 minutes. Watch these 4 videos and then take the multiple choice quiz. Some of these topics I already covered in the video for homework 1 and 2, but I wanted to do short videos to talk about it more. But now it's a problem because it's locked, and I locked it so you can't open it yet, which makes sense, but then you don't know that you have to watch these videos. So now you know, but I have to post it in the announcements, okay? I think maybe I have to figure it out because I want to make sure that you know. Everybody is hearing me? You have to watch these 4 video lessons before you take this quiz. You have to watch these 4 video lessons before you take the quiz. Okay? All right. I think I will put this dot, I will change the date of this dot product lab activity. So it's not due tonight, because you didn't even have time to work on it, okay? in class. But those of you who don't have homework in other classes, you might want to start it. But okay, so I need to deal with those two things. But so since we have only 7 minutes left, I would like to go over the syllabus. Okay, can everybody see the syllabus?
Yep.
Yeah? Okay. Okay, these are the things you're going to get out of the class. Here are the teachers, the office hours, and our Zoom links. Here are the class hours. Lecture and lab are taught via Zoom during the scheduled class period. Enter the Zoom classroom via the Engineering 35 Canvas course, confer Zoom, and the password is capital ENGR35. Okay, and this is the password for both lecture and lab. Attendance is mandatory. You're responsible for material missed when absent. Please meet with Joanne or Rob during office hours if you have difficulty attending class. So again, because of COVID, the fire, how you've been impacted, you may miss classes. Tell us if you need to miss stuff. But basically everything is going to be recorded and posted. Okay? Since it's a 5-hour per week class, prepare to spend 10 to 15 hours. Again, those of you who are not going into electrical engineering or not going into mechatronics, this class is way, way more important than physics 4B. You may never see electricity and magnetism. Those of you who are civils, you probably shouldn't even have to take physics 4B, but you do. Okay, textbook here. Miles, here's the list. Here's where the textbook is. So going back, I'm noticing that I didn't say that everything will be video recorded and I will post it on the module. So in a few hours, I will get this recording and I will post it under this today's module. All the modules will be organized by date. Okay, you need a scientific calculator. You need one that solves a 6x6 matrix. Any of those TI 84, 83, 82, 89, or whatever they are, they all do it. Okay, you need it. You need it. And you're going to need it forever, and you need it in circuits too. And the reason why is because you're going to be solving 6x6 equations, 6 unknowns, 6 equations. And you can't do it in your head, and you can't do it by math. Well, actually, you can do it by linear algebra, but it'll take you a long time. You need a calculator to crunch it out for you. Engineering paper and a 3-ring binder. It's very important, even though we're doing everything virtual, you really want to be organized.
Joanne, I have a question.
Yeah, Angel.
So for those calculators, you said scientific calculator, TI 84 and 80, all those, but those are like graphing calculators, right?
Right.
So if I were to, because I recently got, or I've had this calculator for like a long time, and it just started like malfunctioning. And so I was thinking of getting like a scientific calculator, like a TI.
Okay, I'm looking, Angel, I'm looking for you so I can see what you're talking about. But it's okay, forget it. Just keep going.
Well, I had a TI 84 and it stopped working. So I was gonna buy like one of those like black ones, like the TI 36s, I think. But I'm not sure if those can solve 6x6 matrices. Since,
okay, so you definitely need to get one that does a 6x6 equation. So I have in my hand right now a TI 30XA, and it is only a scientific calculator. It does not do matrix functions.
Damn.
All right, but check with Kelly in the STEM Center. They might be giving them out. You know, there are so many resources. You don't have to go out and buy a calculator, but you need it.
Okay.
Okay.
Sounds good.
Okay. Homework assignments and due dates are posted on the module. submit the homework as one saved PDF file. Okay? You have to figure out how to do this. I want only one file. And about 5 of you gave me files that were upside down or sideways, and then I had to turn it around. Every time that happens, it takes more time for me. And I don't want to be spending time on that kind of stuff when I rather be helping people with statics. Okay? I do not take light homework. However, everybody is dealing with stuff. Please communicate with Joanne if you have difficulties submitting homework by the due date. And then I'm going to post all the solutions to the homework on the module. Statics is built on each other. You can't do homework 3 if you didn't do homework 1 and 2. You can't do homework 10 if you didn't do homework 9. So you got to keep up. You got to keep up. And that's why homework is going to be due twice a week. Here, I'm grading all homework out of 3. I'm not checking the numerical values. I'm checking the setup. So as long as it's presented professionally and it's complete, you'll get full credit. And then I'm always writing a comment that says, check the solutions with my solutions. Okay, lab activities. Friday's lab time is set aside for activities including worksheets, problem sets, and virtual physical activities. Lab activities and their due dates are posted on the module. They're graded out of 10. They'll not be accepted late either, but if you have problems, talk to Rob. And solutions to the lab activities will be posted as well. I'm telling you, if you don't have stuff like, if the COVID thing and the fire thing are not impacting you, and you're just, relaxing and not being on time, you don't want to do that. The only reason for late stuff is if you have big shit going on. And I'll totally take things late. Okay. There will be, notice it says here, in-class quizzes, in-class quizzes and online quizzes, and there are no exams. I'm not going to give you 1.5-hour exams to take in class. Instead, we're doing quizzes, and we're going to have a bunch. In-class quizzes will be administered during the first 15 minutes of every Tuesday's lecture. So that means next Tuesday we have a quiz. The topic of each quiz will be posted on the corresponding module. Each quiz will be graded out of 10. After the quiz is graded and returned, students may redo the quiz to get 25% points back. A one-sided 3x5 index card may be brought into the quiz. And preparing your cheat sheet is a great form of studying because it causes you to review the concepts and organize your thoughts. I know I'm going a little bit over. Whenever I go over, I'll give you the time back another class. There will be online quizzes that'll be multiple choice, and you're going to be able to take them at your own time between the allotted time frame that I give you. So I might say, take it any time on September 2nd. You can take it whenever you want. Each quiz is graded out of 10. Students may take the quiz a maximum of 3 attempts to get the highest score. And again, you could have a cheat sheet. And then there's a final exam given during the final exam period. In addition, I'm going to be conducting interviews with you each. Periodically, there will be scheduled instructor-student interviews where students have the opportunity to share their static skill orally. So I'll meet with each one of you individually and do that. And then we're going to have a small individual design project. Actually, we might be able to do a group. We'll see. And then this is the final course grade is 15% homework, 15% lab, 10% in-class quizzes, 10% online interview, design project, and the final exam. Okay, I'm going to stop sharing. Okay. Questions?
I have a question.
Angel.
So for the in-class quizzes, will we be knowing like the content of those quizzes beforehand? Like,
Yeah, you'll know the topic ahead. It'll be written on the module.
Sounds good.
And then you could also ask me on Thursday too. I'll tell you yeah, okay?
Is there any calculator that we can't use?
I know, you could use whatever you want.
Okay, thank you.
I mean, yeah. I don't know. I don't know what the reason for that question, like if it
Math
has the
classes
whole
ban
text,
graphing
if it
calculators
has the
usually.
whole textbook
Yeah,
on it.
certain classes they might restrict a calculator because it does too much work for you.
Oh, maybe in a math class, but I don't care if the calculator does the 6 equations, 6 unknowns for you, or 3 equations. In fact, I'm going to teach you how to use the calculator to solve matrix operations and stuff like that. I mean, there's some calculators that are like a computer and they have the whole textbook on it. It doesn't matter. In the end, you have to follow the procedure of step by step, the way Rob and I are teaching you how to solve problems. And, you know, the math isn't the part that you'll see as we go along. I'm going to just go back to that module again.
Hey, Joanne.
Yeah.
So for the calculators, you said we should talk to Kelly if she possibly has extras.
Yeah. Is that Daniel?
Yeah.
I'm trying to get you guys, figure your voices. I'm usually pretty good at that. Yeah, talk to Kelly. I don't know what, well, you don't have to talk to Kelly. Just go into the STEM center, the virtual STEM center, and ask if there's calculators.
Cool.
Right? If somebody has the chat, so what do you need to do? So certainly look at the calendar and I'll show you what homework you need to do. I definitely want you to look through, you know, in more detail, this Tuesday thing, this Tuesday module, right? And watch these videos. And so I have a few things to do. One, I need to change the time of when this dot product lab activity is due. Let me write that down. I also need to give you the description. I'll probably what I'll do is under the homework section, actually under quizzes, I'll figure it out. But on this module, I'm going to watch these 4 videos. Okay. So watch the videos. And was there something else I needed to do? I think that's it. Okay, stop sharing and let's see if there's any, do you know if there is an app for an iPhone? I bet there is. I have no idea though. Through the App Store, I didn't see if this is. Okay, what I would do too is, actually, I'm gonna go back to sharing. Everybody pay attention to me, please. I'm going to discussions. Okay, because I know everybody's looking online now for an app for the iPhone. Please don't do that. Do that away from me. Use me right now. So under discussions, there's a Q&A discussion. And I started posting questions. You should post stuff in here. Like if ever somebody found an app, put it in here. Somebody's trying to figure out a cheaper way to get a calculator, put it in here. This is a way for you guys to help each other. Okay? Okay, I'm gonna stop sharing. Okay, looks like I owe you 5 minutes. Okay, any last questions?
No bridge competition?
No, we can't compete. We can't be close.
We can share scores. Everyone go get dowels. We'll do it.
And take videos of our own bridges, yeah.
That's right.
Do you want to do that? I mean, Grav and I came up with this other idea of a project, which is, you know, which I think will be more helpful for future classes.
All right.
It's the project is for you to come up with some physical device that you could use to describe one of the many statics things we're doing. And I think that might be nice for us to have in the labs too for future semesters. So even though a bridge competition might be more fun, I think it might be more practical. to have this. And then the bridge competition thing is going to take a lot of time from you. And I'm not quite sure you really have the time to devote to a huge design project when you're doing all the online teaching. So we could talk about it in the future, but that's my gist of it. Okay, see you guys. I owe you almost 10 minutes. Maybe Rob will give it to you on Friday. I'll have to talk to him. Okay, see ya.
Thank you, Joanne.
Hope you're excited about statics.
Thanks, Joanne.
Thanks, Joanne.
Thank you.
Okay, bye.
See ya.